Okay, hopefully you recognized a pattern in the numbers that were given to you, but it did not ask you to extend the pattern or recognize the pattern. It asked you to find a geometric representation. So you're going to have to kind of switch your thinking now from being so algebra minded to now being geometry minded. And in geometry, we're all about shapes and figures and solids. So if we want to represent these numbers in a geometric way, we're going to do so by drawing some figures that have these numbers as their representation. So if we're talking about a three-sided figure, you would guess that we are talking about a triangle. So this geometric representation of 3 would be a triangle. 4, you could draw any quadrilateral. You might immediately think of a square, but it could be a rectangle. Pentagon would be the 5-sided figure, kind of looks like a house. And then we go to the hexagon, which is 6-sided. So it might get a little more challenging there. And then a 7-sided figure is a heptagon. So don't judge on the shape of my heptagon, but trust me, there's 7 sides there. So that's a geometric representation of that series or sequence of numbers. Okay, so today our objective, the things I want you to be able to do, I want you to be able to describe what a point, what a line, and what a plane is. But I also want you to be able to use physical models in our world to represent these geometric definitions. I want you to be able to define them, but I also want you to be able to use correct notation for lines and segments and rays and angles, angle bisectors, and know what collinear points are. So we're really going to be focusing on definition and notation today, and this will be, this information we're laying down today we'll use for the entire year. So from here on out, when you are using notation to represent a segment, I'm going to expect you to do it correctly or you're going to miss points because your notation is really, really important in geometry. So it may seem like we're being really, really picky here, but trust me, there's a reason for it, and at the end of the year you'll understand why we're so picky. So before we get started, I want to talk to you for a moment about letters. So I'm pretty sure you know the 26 letters of the alphabet, but what I'm being more specific about is the casing of letters, meaning are we writing uppercase letters or lowercase letters? And so a lot of times we don't really pay attention to our uppercasing and lowercasing unless we're writing sentences in English. We know to capitalize the first letter of a sentence, for example. But if you're just writing on your own, a lot of times you like to write your name maybe in all lowercase letters or write your name in all uppercase letters, you know, whatever you think looks the best. But in geometry, it's really important on your casing of your letters because they mean different things. So for example, a capital A and a lowercase a in geometry mean two totally different things. A capital A represents area. A lowercase a represents something you've never heard of, which is an apothegm, that you'll learn about an apothegm this year in geometry. So when I'm telling you how to write your notation for these things, really make sure that you're paying attention to the casing of the letters and that you're also using that when you're using correct notation yourself. Okay, so I'm going to show you an animation from Agile Mind, and this is a little difficult to do, I know, on the ladybug, but just bear with me for a moment. So we're going to start off with 3 terms that we call them undefined terms. It doesn't mean that we have no way of describing them. It's just there's not a formal definition of these words. And that is point, line, and plane, the most basic forms of geometric objects that we have. So you can see here once I start. And by the way, when we're going through this, you're answering problems or numbers 2 through 7 on your notes, and then I'll make sure you have the correct answer. So if you miss one, don't stress too much. I'll go over them in just a minute. Okay, so we can see in this animation that we have a point, we have a line, and then we have what's called a plane, not an airplane, a plane in geometry. And so it's telling us here it is possible that we can describe these things, but mathematicians just aren't able to give them a formal definition. So that's why we call them undefined terms. Okay, so a point, it is on your notes. A point has location, but it has no size. When we are going to name a point, it is important that you label them with capital print letters. So no lowercase and no scripting here. They are capital print letters. So you can see there's several points here. Here's point C, point B, point E, point S, but they're all capital letters. We think of them as dots, but we call them points in geometry. All other geometric objects that we're going to be talking about are made of points. So number 2, you should have capital letters. Okay, so a line, you have the definition on your notes, is made up of an infinite number of points. It extends infinitely far in opposite directions. So infinite, that means something we cannot count. It's not finite, something that we can count. It's infinite. It's uncountable. And so, you know, Buzz Lightyear, to infinity and beyond. That's what we're talking about. So we can't measure a line because it has no distance. I can't measure the length of this line because it is going on forever. That's what those arrows are showing us. So we have 2 different ways to name a line. The first way uses a little symbol that looks like a little line, and you put it over 2 points on the line, any 2 points. Now on this line we're only given 2 points, so I can only name this one line J-I or line I-J. The order of the letters doesn't matter on a line. Okay, so a little symbol for lining above, and either J-I or I-J. So this one would be line E-A or A-E. The order doesn't matter. Again, uppercase letters, because those are points that you're talking about, and just block letters, print letters. You can also name lines using a lowercase scripted letter. So this letter K right here is not a point on the line. If it were a point, it would be a capital print letter, but it's not. It's lowercase and it's scripted. So another way to name this line would be to use the word line, not the symbol, the word, and use that lowercase scripted letter. Now you cannot name a line by 1 point on it. So I can't call this line I. There are infinitely many points that could go through point I. I could draw a line here, I could draw a line here, here. I could keep drawing all these lines through point I. So I can't just name a line by 1 single point. You have to use 2 points to name a line. This is not a point. That's like the line's name, like giving it a name. So its name is line K. Okay, lines do not have any thickness, and again, they do not have a length at all that we can measure. They go on forever. They have infinite length. Okay, so the next thing we're going to talk about are line segments. Line segments are simply a portion of a line. It's the portion between 2 specific points on that line. Those 2 points are called its endpoints. So here is segment JI. It was a portion of the line that we began with. But this segment starts at point J and ends at point I, or starts at I and ends at J. It really doesn't matter. The distance, the direction doesn't matter. Okay? So to name a segment, you name it using its 2 endpoints. And so you could name this one with a segment bar this time. You're not going to put the arrows at the end. So you would name it segment JI or segment IJ. Again, the order doesn't matter. Now, to write those 2 letters by themselves without a symbol above it means you're talking about its measurement, how long it is. So if we measure from J to I, we find it's 2 centimeters. So make sure anytime you leave the symbol off that you're talking about its measurement. You're representing a number there. This does not represent its measurement. This represents the segment itself. So you use the symbol when you're naming the figure. You do not use the symbol when you're giving its length. Okay? So that's very, very important. So the distance is represented with no bar over the letters. Okay, so the next thing we're going to talk about is array. An array is also a part of a line, but unlike a segment, it starts at a specific place, but it doesn't stop at a certain place. So this one, for example, this array starts at point A, but it goes on forever in this direction. That's why the arrow is there. So when you name array, you're going to use a symbol for array, which looks like a little tiny ray above the letters. Again, you're using capital print letters for the 2 points, but this time there's only one way to name this array because you have to start with the end point, the point that doesn't have an arrow at it. So you have to name A first and then the E, or any other point that was labeled on here. So if you had other points given on this ray, you could name it ray A and then whatever one of the other points are. Okay, but you have to start with the endpoint. Just like a line, you can't measure a ray because it's going forever in that direction. So it's not measurable. It has an infinite length to it. An angle consists of two rays that have the same endpoint. So here's that ray we just looked at, ray AE. If I draw another ray that also starts at A, now I have created an angle. This is an angle. The point that they have in common is called its vertex. So this angle has vertex A, this angle has vertex I. The rays are the two sides of the angle. Now notice on this angle it doesn't have arrows at the end, but that's still an angle because I could extend that forever and I'm not changing the amount of rotation between those two segments. So it doesn't matter that there's not arrows there, that is still an angle. Now when we name angles, we have a couple of different options. You can name angles with 3 letters, but the middle letter has to be the vertex. So I can name this angle angle EAF or angle FAE, but A has to be in the middle. I couldn't name it angle AEF. That's out of order. You can also name an angle by its vertex letter alone if there's not another angle with that same vertex. So like, for example, if I extended this ray and made it a line going through A, well now I have 2 angles that have a vertex of A. So I couldn't just say angle A because I wouldn't know which one you're talking about. But since there's not another angle in this drawing that has A as its vertex, we can call it angle A. You can also name angles by numbers. So we can write a 1 inside that angle and call it angle 1. Notice the symbol for an angle looks like a little angle and you put it in front. And again, these are capital block letters or print letters when you're naming these points as part of that angle. Now, when we start looking at making generalizations about these figures, we need to understand that what makes them up to make these figures. So for example, we need to be able to name and represent these objects using the correct notation. So we just learned how to name an angle. Now when we're talking about how much it measures to be, it has to look different. So no longer are we just going to say angle 1. We're going to put this little m in front, which means it's the measure of angle 1 that we're talking about. Similar to when we were talking about the segment length. We put the segment bar above it when we're talking about the segment itself. We removed the bar when we were talking about its measure. Well, with an angle, you add the little m in front to say you're talking about its measure. This is its name, this is its measure. So we measure angles in degrees at this point. We'll learn another way to measure angles at the end of the year called a radian. But for now, we're just sticking with degrees. So all of these geometric figures are located on what we call a plane. A plane is a flat surface. It extends in all directions. So if you imagine the wall at the front of the room that the smartboard's on, imagine that wall going forever up, forever down, forever to the left, and forever right, and that it was flat, not didn't have the creases where the mortar is, okay? So that would be a plane. That would represent a plane. You have points on that plane, you have lines, you have angles, you have rays, you have segments. All of those are located on that plane. So on this plane right now, we have 6 specific points that are named, but there would actually be infinitely many points on that plane. It's just they have located and named 6 of them. So all of these points, since they're on the same plane, we call them coplanar points. If they're on the same plane, they're called coplanar. These points I could connect and make a line. So I would say if I draw a line through them that S and C are collinear, meaning they're on the same line. Okay, so if they're on the same line, they're collinear. If they're in the same plane, they're called coplanar. When you name a plane, you have 2 options. You can name a plane with any 3 points on it. Okay, so this is just one option, plane KCS. I could name this plane DBE. I could call it plane ESK. Okay, any 3 points on the plane can name it, but make sure you use the word plane. We don't have a symbol for it. You can also name it using an uppercase scripted letter that's its name. So notice this is not a point. It's not a capital print letter. It's a capital scripted one, so it's its name. So I could call it plain R as well. Just like with a line, we can name a line with 2 points on the line or with that lowercase scripted letter and say line, whatever that scripted letter is. Okay? We already talked about this. Points that lie on the same plane are called coplanar. All right, let's make sure you have correct answers for 2 through 7 on your notes there. Points are named and labeled with capital print letters is number 2. What are 2 names for the line that contains point A and E in the figure? You can name it line with the symbol AE or line EA. This particular line doesn't have a scripted letter, but if I gave it a scripted letter, like a lowercase scripted L, I could also call it line L with that scripted letter. Points that lie on a line are called collinear points, so E and A are collinear. Points J and I are collinear. Number 4, what is meant by these different notations? Remember 2 letters, capital letters with no symbol. This means the measure between those 2 points, or the distance. That's another way of saying that. The measure of it, or its distance. This symbol means that is segment AE, meaning it starts at point A and ends with point E. And this symbol means we're talking about line AE, meaning it contains those 2 points, but it extends forever in both directions. Number 5, how do you name a ray in geometry? You have to use the little symbol for ray, and then you have to use 2 letters. This point has to be the end point where it starts, and this point is where it goes forever in that direction. So what is the name of a ray with endpoint I and a point J on that ray? That would be ray IJ. Ray JI would be incorrect. You have to name the endpoint first. Number 6, how are angle, that's the symbol angle, DBG, and M with angle DBG different? This is talking about the angle itself as a figure. When you put the little M in front, you're talking about its measure in degrees. So for example, we would say the measure of angle DBG equals 40 degrees, whatever it is. Number 7, what's the minimum number of points needed to determine a line? You must have 2 points to determine a line. If you have a single point, I can draw lots of different lines going through that point. But if I give you 2 points, now there's only 1 line that can be drawn through both of those at the same time. To determine a plane, you must have 3 points. But those 3 points have to be non-collinear. And I'll explain why that is. If we draw 3 points that are in a line together, A, B, and C. Imagine a piece of paper. Well, it's on a piece of paper, so there's one plane that contains those 3 points. But I could take another piece of paper and go straight through those 3 points like this. Or I could change my angle and go through those 3 points like this. Or change my angle and go through them like this. So there's lots of planes that would contain those 3 collinear points. But once I draw 3 non-collinear points, there's only one plane that contains all those 3 points at the same time, and that's this piece of paper itself. I can't create another plane that can go through all of those at the same time. So you need at least 3 points, but they have to be non-collinear. One more term that is not mentioned is the term space. We don't talk about it a lot, but space is just, as a term, is meaning it contains points anywhere in our 3-dimensional world. This includes points in a plane and those not on the plane. So, for example, our classroom, it is space. It contains different planes, different lines, different points. It is space. I want you to go ahead and answer question 8 in your notes, and then start the next video when you're ready to check your answers.